Hey everyone, and welcome to this explainer. Today, we are laser focused on one incredibly specific, highly tested subtopic, NCP-MCI 7.5 to 8.2 volume groups. If you want to confidently breeze through the storage questions on your infrastructure certification exam, you really need to know this architecture inside and out. So we're going to establish a clear, authoritative baseline on this today, so you can spot those correct answers instantly and, understand exactly how Nutanix handles these configurations under the hood.
Okay, let's dive right into this. Here is our agenda for today. First, why volume groups matter. Second, configuration and real-world examples. Third, navigating common exam traps. And fourth, key facts to memorize.
Section 1, why volume groups matter.
So let's establish our baseline right away. Why do we even use volume groups instead of just attaching standard virtual disks directly to our virtual machines? Well, a volume group, or VG for short, is essentially a collection of virtual disks, VDisks, that act as iSCSI targets. This setup allows you to serve storage directly to external bare metal servers or to guest virtual machines. Now, let's quickly decode a few acronyms since the exam absolutely assumes you know them natively. AOS is the Acropolis operating system, right? The core data plane. AHV is the Acropolis hypervisor, Nutanix native hypervisor. And crucially for our topic today, IQN stands for iSCSI qualified name. And IQN is essentially the unique identifier we use to securely grant a client access to this storage. So by using volume groups acting as iSCSI targets, we're essentially bypassing the standard hypervisor storage stack. And that is exactly what gives you the incredible flexibility to present Nutanix storage directly to a physical, non-virtualized server sitting right there in your rack. You're treating the Nutanix cluster just like a traditional SAN, but you get all the modern benefits of hyper-converged infrastructure.
Section 2, configuration and real-world examples. Let's look at how this works in practice.
Now, what's really interesting about this configuration is this specific number you literally just have to memorize, 75. When you sit down in the Prism Element UI and type in a name for your volume group, AOS enforces a very strict 75-character maximum limit. And you might be wondering, why so specific? Well, it's because this limit has to securely accommodate the auto-filled iSCSI target name prefix right alongside whatever custom name you decide to assign. If you try to exceed it, the system just throws an error. It's a classic rote memorization trivia question that loves to show up on the NCP-MCI exam. Seriously, lock that number in your brain right now. When you're actually provisioning a volume group, the workflow is actually quite elegant. First, you name the group, keeping that strict 75-character limit in mind, of course. Second, if you are serving the storage to a machine outside your immediate cluster, you check the box to enable external client access. And third, you lock down security by adding the client's IQN to the allow list. Think of this allow list as a strict gatekeeper at the storage fabric level. If an initiator tries to connect and its IQN isn't on that list, the storage fabric just silently drops the traffic. It tells ADOS exactly who is permitted to talk to these VDisks.
Let's look at two concrete, real-world examples of why you'd configure this in the wild. Example 1. Let's say you have a legacy external physical database server, just a standard bare metal server, and it needs high-performance storage from your Nutanix cluster. You just create a VG and connect it via iSCSI over the network. Simple enough, right? Example 2, though, is entirely different. This is when you need shared access. Imagine a clustered application like Oracle RAC or Windows failover clustering, where multiple VMs need to read and write to the exact same disk at the exact same time. Volume groups make this shared concurrent access possible. They allow those specific applications, which are designed to manage their own disk locks natively, to function perfectly across multiple nodes.
But you've got to pay close attention to a massive caveat here coming straight from the Nutanix documentation. If you allow multiple VMs to write to a shared volume group without using clusterware software, like that Oracle RAC or Windows failover clustering we just mentioned, you are going to cause catastrophic data corruption. I mean it. Without clusterware software managing the locks, you create this awful split-brain scenario. Two virtual machines might attempt a blind overwrite on the exact same block of data simultaneously. The volume group itself provides the shared high-speed pipe, absolutely, but the guest operating system software still completely relies on that clustering logic to prevent destroying the data footprint.
Section 3, navigating common exam traps.
Okay, so that severe warning brings us perfectly into navigating common exam traps. This is where we uncover the specific edge cases the exam writers are going to use to test your deeper understanding. Here's a direct scenario you might face. Can you allow a list a client for a volume group using its IP address? I'll give you a second to actively think about that specific configuration scenario. So the crucial point here is that AOS absolutely does not support using IP addresses in a volume group allow list. You must use the IQN. And why is that? Well, because an IP address is inherently mutable. DHCP leases expire, networks shift around, and IPs are honestly highly vulnerable to spoofing. An IQN, on the other hand, is a hard-coded, unique cryptographic identifier for that specific initiator. If you see a multiple-choice answer suggesting you should secure a volume group by typing in an IP address, recognize it immediately as a trap and just eliminate it.
Next up is what I like to call the mutual exclusion rule. A volume group configured with client iSCSI initiators cannot be directly attached to a VM in the cluster at the exact same time. Nutanix simply does not support this mixed mode configuration. And the reason for this is that the storage fabric just cannot safely arbitrate between a direct internal SCSI attach and external iSCSI commands happening simultaneously. So you either attach it directly to a VM as a SCSI disk via the Prism interface, or you serve it out externally via iSCSI. You literally cannot do both simultaneously on the same volume group.
Let's walk through a few more of these architectural constraints, because these are prime distractors on the exam. First, never use a volume group to create an iCSI data store for ESXi or Hyper-V hosts. It is strictly unsupported. Second, you cannot live migrate volume groups using cross-cluster live migration. The binding constraints between the host and the storage fabric simply don't allow for that clean handoff between entirely different clusters. And third, volume groups can't be attached to a consistency group that's configured for application-consistent recovery points. Just knowing these edge cases is absolutely key.
Section 4. Key facts to memorize.
All right, let's lock all of this in. Consider this your ultimate rapid-fire cheat sheet for the volume group subtopic right before you walk into the testing center. Rule 1. The naming limit is exactly 75 characters maximum. Rule 2, for your allow list, it is client IQNs only, never ever IP addresses. Rule 3 is the attachment limit. Remember that iSCSI initiator access and direct VM attachment are mutually exclusive. And Rule 4 is the data store rule. Never use volume groups as data stores for ESXi or Hyper-V hosts. And really, this brilliantly illustrates Nutanix's whole design philosophy. Clear, strict boundaries that ensure high performance and absolutely zero ambiguity in your storage paths. So, I leave you with this final thought. How will you leverage these strict volume group boundaries to guarantee success on your NCP-MCI 7.5 exam? By internalizing these rules and really understanding exactly why Nutanix enforces them, you won't just pass the test. You're going to be a far more effective infrastructure admin in your day-to-day operations. Thank you so much for joining me for this explainer. Keep studying hard, trust your structured knowledge, and best of luck on your certification journey.